Hey there, welcome back everybody. We have a very cool tour today. We are here at, it's not Ouroboros Fabrication anymore, it's now called Ouroboros Space and Defense. They haven't gotten a new sign yet. They're actually moving in a couple of months to a 3 times larger space. But we're gonna tour this one first. So we're gonna be interviewing and talking with Nathan, who is the owner and founder of this business. He was on my podcast, Machine Shop Mastery, and incredible story, incredible founder. So check that out if you haven't heard it yet. But yeah, they do incredible 5-axis and multi-spindle machining here. They have an incredible welding capability as well, which we will get to see, not up super close. One unfortunate thing is they pretty much all do ITAR parts, so we're not gonna be able to really see many of the parts themselves, but we will allude to them and talk about them. But they are doing some really cool stuff here. So let's go in and check it out. Nathan, good to see you, my friend.
Great to see you.
Thanks for having us.
Of course, anytime.
So, yes, I'm so excited to be able to have you open your doors to show the shop. Obviously, we can't show many of the parts. That's okay. I'd love for you to just take a minute and tell people a little bit about the founding of the company and the background and what you guys specialize in.
Yeah, so we started in 2016, primarily doing fabrication for the automotive industry, custom race car components, turbo kits, that kind of stuff. Decided after a few years doing that welding work that I wanted to work on aerospace components. Moved on to getting our D17.1 and doing some work with supersonic jet stuff around town. After enough of our customer base for the welding side kept on telling us that, hey, we'd love to have you machine parts and weld them. We took that input from our customer base and decided to buy a 3-axis mill. From there, we kept on doing a little bit more and a little bit more complex components, and now all we do is 5-axis machining or 5-axis to 9-axis machining for the space industry.
Okay.
So that's our specialty is in turbo machinery at this point.
Yeah. So the parts are absolutely amazing. I really wish we could show them, but understandably we can't. So, and I love this lobby. This is just, well, tell us about how you decided.
Yeah, so we're fairly dedicated to the space industry, I would say. We wanted to kind of embody that this first facility is dedicated to our push towards Artemis and bringing people back to the moon, and the next facility that we're moving into shortly that I'd hope to be able to take you there, but we're going to be there in about a month or two. That one we're doing a Mars landscape because that's our next step as a species is to go on to colonize another planet.
Awesome. All right, well let's get into the tour.
Come on back.
Love coming into this space. It's just machines everywhere. All right, let's start here in tooling. You have standardized on RegoFix. Tell us about your choices for tooling and holders.
Yeah, so we had the RegoFix tool rep come by and let me do a Coke Pepsi challenge on tool life and finish just in this 3-axis mill, being able to try PG25 against an ER32 and just the same tool path, same tool, same everything. The finish was far superior with the power grip system. So I decided early on that I wanted to standardize what type of holders we use and what type of tooling we use and just take one variable out of the equation as far as, is it the tool, is it the holder, etc. When we were working on complex components, I want the guys to have as little of that kind of stuff to worry about as possible and be able to focus on the problem at hand, the actual complexity of the part or the tight tolerance nature of it. So we decided to go for the power grip system, and we've implemented it on all of our machines at this point. We will probably add heat shrink in as well in addition to it at some point, because there are some features that just will fit better for, and having that option will be something that we utilize. But for now, this has been an awesome system, and I know that it's been easier to work with than
heat shrink.
Yep.
And it looks like they have a really wide variety of different types of holders.
Yeah.
And
so
obviously specializing in 5-axis, you sometimes need to get really long reaches. So tell me again, what kind of concentricity and run out these things are maintaining?
Less than a 10.
That is absolutely incredible.
Yeah, unless there's something wrong, and then we'll see it. We can see if there's something wrong. If there's more
and you can tell that on your on your presetter here?
Yep, we set all of our tools offline, so then we're able to let the machine stay in the cut while we're loading up a full job worth of tools.
Yeah.
Touch everything off, or we can either set it on the Uno and be able to preset there.
Yeah.
And our goal is to use the RFID system so that we
Okay.
can just load tools into the machine, and there's no option for a fat-fingered.
So you just
there's a
upload
decimal missing.
that. Oh, it has it embedded in the chip. It just directly reads it as
Yep.
it puts it in.
Yep.
That
That's
is
the game
really
plan.
That's pretty cool.
But we'll
Yeah.
get there.
Yeah, sure. So I just want to touch on something, talking about the standardization. So you're really trying to just eliminate process variables, right?
Exactly.
Because the parts you're doing is so complex. You can make one totally standard. It's not a variable anymore. You can focus on the other things.
Yeah, just to find the thing that works
Yeah.
and go with that. And obviously we still do testing where we'll have a tool rep come in and say, hey, try this against whatever you're using.
Right.
And I want to make sure that we don't stay stubborn in our standardization,
Sure.
but that we are able to limit our choices we have to make at day-to-day basis.
Okay, cool. Well, let's come around, check out this big DMU 95. And I see you've pretty much standardized on double screen monitors pretty much everywhere, it looks like.
Yep. I like to have it where you can have the work order open in one side and then your prints open in the other side, and
Yeah.
still be able to work from there. But we also, on a lot of our machines, we're running either two ops or two different work orders. In this machine right now, we have a pretty good sized tombstone running, and on two sides of it, we have an op 1 of one part, an op 1 of a different part, an op 2 of the first part, and an op 2 of the second part.
Okay.
So we get finished components done with each cycle, and there's finished components of two different work orders coming.
Yeah.
That
Are
helps us
those-
stay.
Are those like a family or a paired things that go together? or
There's
just
similar components. So the geometry allows us to have similar
Yeah.
approach, similar tooling, things like that.
Right.
But they're not, a pair of parts that go together in the assembly. We do
Got it.
have similar volumes though, and similar lead times. So
Right.
instead of us getting really lumpy in our workflow, where we have one part's caught up and then the
Sure.
other we got to fight to catch up or whatever,
Absolutely.
we're just able to make sure that we're staying on track with both.
And you're trying as much as possible to have that sort of one piece flow. I mean, in this case, it's many pieces, but finished parts through the process as much as possible. No more
Absolutely.
batching and queuing.
Exactly.
Yeah. And what do you find to be the benefits of that versus? Because a lot of shops still kind of do like, let's set up all of op 1, and then break it down to op 2. So I know why I like it, but just I want to hear your version.
Yeah, I looked at that, the traditional like five parts in a cell example that they use in pretty much every Toyota method or Kaizen training, where you see the difference in time from having the first part come off the end of the line, doing a
Right.
single piece flow versus like a 5-piece batch flow.
Sure.
And you can increase your throughput by 100%, depending
Yeah.
on other variables. But
Sure.
it's crazy how much more efficient things can be in a true single piece flow.
Yeah.
And I've tried to take as much of that approach as fits well for the type of work that we do,
Right.
but also not be, putting a square peg in a round hole.
Sure. Sure.
And trying to roll with that and utilize as much of the TPS system as we can.
Sure. And I imagine you consider cycle time versus tool changeout time and part changeout time to balance, because in this case, looks like you're doing about 10 on each side.
Yeah, we had been doing 10 and our fixtures set up for 10,
Uh-huh.
but they were about 8-hour cycles. And we
So
said,
this
okay,
thing
that's
should run
perfect.
for
So
8
then we could
hours.
run 24 hours a day. But
Right.
then when you take changeover into account and, oh man, somebody was, on a break or something when the
Right.
cycle came for a change, we ended up running twice a day, more often than 3 times a day.
Got it.
So we decided, okay, let's drop our actual part count on this from 10 to 8.
Yep.
And then now we actually get 3 cycles per day.
Oh,
So
nice.
that took
Okay.
us from a hypothetical 60 a day components to, we had actually been at 40.
Got
now
it.
we're at 48.
Sure.
So the increase of 16% there that's a big increase.
Yeah,
That's,
absolutely.
most
I love
of
the
margins
logic
on a job.
I love it. Awesome. Cool. All right. And you have another DMU 50 over here.
Yep, we're making some pretty fun parts that I wish I could show you, but so it is.
And
Making some
I know
cool
you were
impellers.
talking, when we talked previously, you talked about just the incredible stability, holding tolerances of these things. You wanna
Yeah, I
share
love
about
these.
that?
Yeah, the DMU 50s have been awesome. The DMU 95 was my first 5-axis machine that I ever bought or ran.
Uh-huh.
So I love the DMGs. They're awesome machines. But one of our employees was pushing for a smaller DMU-50 because he had run one at a previous job.
Yeah.
So I said, I'm going to take the feedback from the crew. They are the ones that are making these parts. So we bought this one, and I thought that thing was accurate. The stability of, it's a smaller workspace.
Sure.
So there's less total thermal play. And they just are dependable. They're workhorses.
Right.
So we got this one about, I guess, almost a year ago. Okay. And after having it for 3 months, we're like, okay, this is great. We're going to buy another one.
Yeah,
so
there's a new one.
It's on the other side.
Yeah.
But we're getting pretty full. So we've got to get into that new space soon.
And we have a Smart here with a fixture plate with how many parts at a time?
There's 96 components for the Op1, and then there's 96 for the Op2.
Okay, so 96 finished parts.
96 finished parts every cycle.
Yeah, and again, we can't show them up close, but they go on satellites. So let's proceed. Yeah, I mean, you've been in business now about 8 years, and your customer list is like the creme de la creme. Just tell us a little bit about, I know you shared that in our podcast interview, Machine Shop Mastery, and I encourage everyone to go listen to that. It was an incredible, I think my favorite episode ever. But just real quick, how did you get your foot in the door and make a name?
So I think that there was an equal mix of just like dedication to like, I know what I want and I'm going to go out and get it. And there's some luck to it too. And just being able to not go out of business, to be able to like roll the dice enough times to be able to let those statistics play out.
Right.
That was a big part of it. But being able to go and hunt for, if you have a vision for what you're trying to do, it makes it a lot easier to actualize that vision. If you just try to be everything for everybody,
right,
you're never going to succeed at anything.
Sure.
So we really decided, you know what, we are specialized at difficult parts. I'm passionate about space exploration and rocketry, so I want to work for those industries.
Yeah.
So we would just show up everywhere that we needed to be for that to be applicable.
Yeah.
So,
I think having a clear vision, and you even talked about in the interview how you set specific, multi-year plans and specific platforms you want to make parts for.
Yeah, and I think the more specific you make your goals, the more likely they are to be achieved.
Yeah.
It's really hard to hit a target that's fuzzy.
Yeah.
So.
Yeah. All right, let's check this thing out. Obviously, tell us about this machine here.
Yeah, so we got this one about a year and 3 months ago. It's a 9-axis mill turn machine, so we're able to do 5-axis milling in it, turning on it. It has twin spindle, lower turret with live tools, and the milling D head. So we use it for everything from just another 5-axis machine to making shafts with integral dog drives and things of that nature, turbo machinery,
right,
impellers, turbine wheels, that kind of stuff. So it's a very capable machine. We've been getting up to steam with it. These are really designed for production environments.
Sure.
It's not the fastest tool change in the world. It does take a lot of work to set up this machine.
Yeah.
So doing prototyping with it has been something that's challenging,
sure,
but helped us get a lot better at that setup time and kind of reining that in.
Right.
Where now when we want to start a production job, we can get those first articles back much, much faster than if we had only been doing production on it for the entire time we had it. But
got it.
It's been an awesome machine. It really increases our capabilities in that market that we want to chase.
Right. And I just want to talk about, I'm going to block out the name, but this is your work order, Traveler, right?
Yeah.
This is how you track jobs. So no big paper packets, no inspection sheets.
Nope.
Can you share a little bit about that?
Yeah, I wanted it to be as minimal as possible so that there's just a brief image of the component, so you can, if you
visually
dropped them all on the floor or something, you could figure out which one's for what. But besides that, I don't want anyone taking any information from the paper side of things, because that's not a master document. If there's a rev that happens,
date
the
changes,
rev is in
rev changes, anything changes. Yeah.
And we would go back and update our Traveler if there's been a revision or something, because obviously you see that that's the second rev on that part.
Sure.
So we would update the Traveler, but just to have there not be a possibility for somebody to pick up something that's paper and make a part to the wrong revision.
Yeah.
That's been huge, and just to kind of force the hand to we have a QR code scanner at every station.
Yep.
So you walk up, scan that, clock into that work order, work through that, ship it. And they are very easy to just send along with your cart of components to make sure that we have traceability.
And if you split a partial, do you just print a second QR code?
Yep.
Yep.
We're moving away from having, I really don't like doing partial work orders where we have different parts from the same work order at different points in the manufacturing process. It just gives ambiguity as to like, is this part cleaned yet or not?
Right.
So I don't like that. And there's also, from what we're talking about on single piece flow, the smaller we can make our work orders, the more functional that single piece flow type of mentality is.
Sure.
So we're moving now to a batch size that is what fits on a cart.
Right.
And we use these small black plastic carts that allow us to, just there's your material, your tools, everything that you need for this job shows up with that QR code.
Right.
You work that until you're through your operation and wheel it off, stage the next op, good to go.
Yeah, and so as part of the logic there, the transactional cost of a work order in ProShop is low enough that you might as well make 10 of them instead of one big one.
To make a work order, especially if it's basically a duplicate of another.
Yeah.
It's a non-issue.
Yeah. That auto create work order button has a little magic wand on it, I think. Even.
Yeah, and it is magic.
And so then just to focus in on that for a second more, so the run together function in ProShop where there's a combined setup, but you're then peeling off, 100, and if you're making a batch of 1,000, you 10 orders of 100. That run together function gives you one setup time, one first article that applies to all of them, assuming you don't break it down again, then you'd have to do a new first article. But I guess that would really help facilitate that concept.
Absolutely, and it's been really great to be able to split a cell, because we have in ProShop, in that DMU 95, we're running 2 work orders at once.
Sure.
We don't need to be charging for the resource twice. So when we're quoting to keep things competitive, I can say I'm splitting this machine into 2, and then I can say, DMU 95 split 1 versus split 2, and have half the resource cost. So then we're able to be more competitive on the components. That thing runs, all day, every day.
Yeah.
And I want to be able to be, not just at a very high quality level, but to me, if you're being really efficient on things, you should be cost competitive.
Yeah, absolutely. Awesome. Well, let's come check out the QC lab. But I guess as we're getting there, what do we have over here? It looks like some cleaning.
So we're doing our clean and pack here. We do just like ultrasonic cleaning. Well, on these components, since they're aluminum, we actually don't use the ultrasonics. We just use the heater.
Oh, okay.
So we use a warm Berlin bath, and then into deionized water rinse, and then convection dry, and then pack. So
got it.
That's kind of our process through there, is to try to standardize the cleaning of them as well. In here, we've got a pretty good sized CMM, so we're able to check the largest components that we can make here, which is 40-inch diameter is the largest diameter part we can do by a 60-inch length. So fits pretty easily on here. So we use a Keyence laser over here. It's been an awesome system. It's pretty fast and works well, but we're building our little enclosure to put it in right now. But we just got our screen in for it. But for right now, we've just been kind of hiding it and everyone look the other way.
Will it eventually move out to the material bay area?
Yeah, actually, we just placed an offer on another laser that we want to use for the part marking side, and then move this one over to materials and be able to use it just for marking materials as it comes in.
Sure.
But obviously here we're in a warehouse space. It's not the type of facility like what we're moving into. So it's been a good place to grow and kind of get our feet wet and start in our processes. But it is what it is, and it's not the type of facility that I know we need to be in and where I want to be. But
I can't wait to come back and do another one at the new space.
I'm excited for it.
So another DMU 50 here. Now tell me, we have this ProShop station, but it's on a mobile cart, so it's on wheels.
Yep. I really like having the toolbox at each station, and have our dual monitors mounted to that. But we're pretty out of space right here, so we kind of rolled with the punches and put it all on a mobile cart, so we can get it out of the way when we need to
Sure.
bring our forklift through and take a fixture out or whatever. But
Yeah.
it's been working pretty well. I think it's a little flimsy, so we'll.
Yeah, we have a
we'll
few
go
clients
another
who
route.
actually have done these with a UPS on it, so they can, have it be unplugged for a few minutes, go plug it in somewhere else, and
Oh, that's
keep
cool.
ProShop up the whole
I like
time.
that.
Again, great fixturing. One part, finished parts off every time, roughing
Yeah.
one side, finishing the next.
Yeah, we're doing 2 op 1s and 2 op 2s. Then it runs for about an hour and a half unattended, which
Yep.
lets us, go do another task and come back in an hour and a half and change it out.
So obviously, you being specialists in turbo machinery, you use the full 5-axis capability of many of your machines.
Yep.
But also for rectilinear parts where you're just coming from multiple sides at once.
Yeah, and even
I know some shops, growing up in a 3 or 4-axis world, and conceptually making the jump to 5-axis, even if they don't have the need for simultaneous, there's so many advantages to fixturing and flow. And
Oh man, yeah. I don't think that even on the parts that would be a great fit for a 3-axis machine, we do them so much faster than we could do them in our 3-axis by putting them in a 5-axis.
Right.
And even the parts that are in our 95 right now, you could do those parts in a 3-axis. There's nothing that's like,
Sure.
swarfed or anything like that. It's not an impeller.
Right.
But we're using 5-axis deburr tool paths on there with a lollipop end mill, so we can get inside of the part and do
Yeah.
everything all at once.
Okay.
And you just can't do that with even a 3+2.
Sure.
So
Yeah.
doing that
absolutely.
made it much, much faster and easier.
Got it. All right. Yeah. Well, that's a vote for the capability of simultaneous, even if your parts aren't,
Absolutely.
like you said, swarf cutting and things like that. So now we're going to welding, which is kind of the origin of the company. And I know, again, we can't get too close because there's some proprietary processes, but yeah, I'd love to have you describe kind of what you've designed here. It's pretty remarkable.
Yeah, so we had a customer come to us. Well, I guess let me back up a little bit. Once we moved over to machining, I've dropped welding off of our docket, really. The only
really?
welding that I was doing was we do like some material testing stuff for NASA where we'll like test samples, or we
Yeah.
make a couple hermetic vessels a year for like ultra lightweight use. But outside of those very, very specialized niche welding projects, I just didn't really do welding services anymore because I couldn't see the economics working out, and the
Right.
scalability of it's very difficult. There's a lot of
Sure.
really skilled welders out there, but
Yeah.
it is so dependent on the individual skill that it's really hard to scale.
Yeah, right.
So I kind of stopped doing welding work, and then we had a customer approach us about 2 years ago, and they sent me some pictures that they found on our website, which was actually
Oh, really?
like a weld from a V-band flange or something on an exhaust. And like, hey, we need 6,000 welds like this a week. Can you do that?
A week.
And I was like, absolutely not, but I'll build you a system that can. So we
Okay.
decided we're going to put the time and energy into building out a system that essentially automates the welding process.
Yeah.
And makes it so that not only is it very, very consistent, but as you can see, Aaron here is running 3 stations at once. So he's able to do the work of one very highly skilled welder.
And Aaron is not a welder.
Aaron, had you ever welded in your life before you came here? No. So no welding background, but is
Right.
making incredibly precise components that are, they're helium leak tested, 100% penetration. They're for the semiconductor industry, and
Yeah.
they have, very high quality requirements for
Yeah,
these
absolutely.
components. And we do 4 welds per valve, about 1,500 valves a week.
Right.
And that's really only possible by doing it in a system like this that automates the welding part of
Sure.
it, where then, Aaron's time can be spent making sure that the system is functioning properly,
Yeah.
troubleshooting, checking components, making sure that quality
Sure.
is consistent, but it's flowing very well. And we do something in here that instead of it being a single part flow, we use a single cart flow. So
Yep.
it takes 48 components from we kit over here, and then they go in and get tacked together. From
Okay.
tack, they run op 1, op 2, and op 2 actually does 2 welds at the same time.
Oh, really?
And then we go back and put a square flange on, because on some of these parts, the square flange is so close to a perpendicular flange that
Got it.
you wouldn't be able to get to the weld.
Okay.
So we put that on last, tack that on, and then it goes to a station that it's my favorite station because it has an arm that like pulls the torch out. So you put the piece in, and then it drops back in and welds it from the inside.
Okay.
That was pretty fun to build. But yeah, we built the whole system in-house.
Wow.
And, you know, there's no...
The creativity blows my mind. And I know there's single cart flow because you have to let them cool down.
Yeah,
It's
exactly.
too hot
Yeah.
to do one piece.
If
flow.
they were, you know, not so hot, we would probably just go one piece all the way through and just have a little conveyor or something. But
and it's incredibly space efficient, right? Like
Yeah.
the amount of work you're getting done in a very small footprint.
yeah, actually, when we first started with that customer, we had this entire side of the company was just dedicated to the welding.
Wow.
And we had 6 10x10 cells that each one was just set up with a welding station, and we had a little rotator there, and we're trying to do it with like, you know, a little positioner and an arm to hold the torch, and then with a little Raspberry Pi program the argon flow through the inside of it with just little valves to open and close, and set a sequence. But we started with that, and then started to improve and improve and improve, and then I sat down one day looking at just the total cost of the space.
Yeah.
Like, man, we need more machines.
Right.
Where am I going to put those? Well, we've got all this space. Man, if we were in Tokyo or something, there's no way that we would have this much space for this amount of welding. I'm sure that we could condense it. So we decided we're going to use, 80/20 extrusion material off McMaster car and just make a little frame and set each station. And I think right now we're still, we have more room than we need to. We can condense it more. And we're looking at, even though we're moving into a much, much larger facility, when we move, we're setting it up tighter so that we can just add more stations to it.
Yeah. It's incredible. The ingenuity and creativity is off the charts. And I think we can actually take a look at one of these, right?
Yeah, so these are valve components that, we've got a pretty good amount of them going through. Some work in progress that we're going into bead blasting. I had not wanted to add bead blasting into our processes here, but our customer needed it, and we decided, you know what, we'll add this in so we can give the whole gambit from start to finish. But the components, as I was saying, like has this square flange on and the round flange here, so we could do 1, 2, 3, 4 welds on each one, and then they get helium leak tested, dimensional check on our granite here, so they've got their shim gauges and squares and stuff to make sure that perpendicularity is where it needs to be. And we don't really have any issues with our process putting any kind of warping into the parts.
Sure.
But if the parts come and one of the bodies or something,
you don't machine these. They come.
No, yeah, we don't do any of the machining. A lot of these are off-the-shelf components, or they're supplied by our customer. So we just get tons and tons of kitted parts ready to rock. But there's obviously some stuff that comes from Taiwan or wherever that the part was a little crooked when we got it, and we just want to make sure that still doesn't make it through to the end product.
Sure.
So.
And I know from the last time you and I just came through here alone, some of your fixturing for all these, that's all in the fixture module in ProShop, is that right?
Yeah, so we have all of our fixtures stored in here, which allow for us to, basically you can go into the part record in ProShop and look at every op and how it's set up, and it has pictures of how do you set this job up.
Right.
And we just had 2 guys start last week that, we brought them on from Papa John's, and they were able to start setting this stuff up and just like, look at ProShop. This is how you set this job up. Here's what you need to do it.
Right.
Off to the races. It's been a game changer to be able to have all of our part definitions and our process in ProShop, to where, if we lose that brain trust of people who understood how to set all this stuff up, or understood where you need to have your, we have external gas coverage systems built onto it. If you lost how that works, or how you set those up, or how much flow you need for everything, that dramatically impacts the end component.
Absolutely.
And now we don't have the risk of that going away with either somebody's out sick, or somebody gets hurt, God forbid, or something of that nature. Being able to have everything stored in ProShop was a game changer.
Yeah. Yeah, I know finding experienced labor is one of the number one issues that any shop is facing these days. And clearly creativity and good tools and smart thinking is one way to actually totally overcome that and eliminate it as a risk of your business. So yeah,
Absolutely.
great work on getting that all done. Cool. So let's see, is there anything else that's worth seeing? Or is this kind of the end of the tour?
This is kind of the end of the tour.
Okay.
For right now, I'm
Yeah,
very
yeah.
excited to take you down to the new facility when we get that set up and
we
see
will-
kind of what we're putting together there. But it's a night and day difference.
Right.
I'm very ready to be in there.
Well, we will come back again and do it again. But Nathan, thank you so much
Of
for
course.
taking us through
Thank
and
you for coming.
kind of opening your doors. I know this is, the growth and what you've done in just a short period of time is certainly inspiring to me, and I'm sure to many others. So anyway, thank you.
Of course.
Yeah. So another incredible tour. Clearly, I think one of the big takeaways here is having an incredibly crystal clear vision of where you want to go, inspiring people to come join you on that visit or on that vision. Really fanatical focus on process control, incredible customer satisfaction, which I know Nathan goes into a lot more in our interview on Machine Shop Mastery. So please do go check that interview out. And yeah, just another one in the books. So thanks for joining us this time. We'll see you on the next tour.